Hello, this is Mr. Zanaletto again. We're going to study today topic number 5. It's our second topic of Unit 2. We're going to be doing investigating inductive and deductive reasoning and laws of logic. First, inductive reasoning. Inductive reasoning uses patterns to draw conclusions. That's the first bullet point we're going to use. Uses patterns to draw conclusions. Now, it can be a useful way to draw conclusions and to have some reasoning behind it. The unfortunate thing is we can't be sure your answer is true or valid. Can't be sure your answer is true, or in other words, valid. In this case, true in everyday life or in the terms of valid, we're really saying there that it doesn't necessarily follow rules of logic or logically sound. When it comes down to it, we really just can't be absolutely sure based strictly on a pattern. In this case, we have conjectures. When we do deductive reasoning, we have a conjecture initially, and we think we see a pattern. Conjectures, conclusions of inductive reasoning. Conclusions of inductive reasoning. And while we're doing inductive reasoning, we're always interested in looking and considering if we can find a counterexample. A counterexample is a situation in which we can disprove a conjecture. And this will be any case in which it shows it to be false. You can be very specific, but if you can find one situation where it's false, that's considered a counterexample, and therefore we have disproved the conjecture. Now, another type of reasoning we're going to study is deductive reasoning. Deductive reasoning is a process of logical reasoning. In this case, we know the conclusion is valid. So we have inductive reasoning where we're following a pattern. Sometimes the best we can do. Unfortunately, we can't be sure of our answer. You don't know in everyday life if it's truly true or if it's really a valid logical argument. In studying those, we have conjectures, conclusions of inductive reasoning. Counterexample would disprove a conjecture. We always have to be looking for those. Moving along, we have deductive reasoning. Deductive reasoning is a process of logical reasoning. Conclusions are always going to be valid in that case. So, go ahead and give you a minute to go ahead and fill this in. We're going to want to go ahead and make a box And there's certain types of deductive reasoning that we're going to study. They're going to be sort of paramount in what we understand as deductive reasoning. And the first one, this upper left box, I'm going to go ahead and put law of detachment. And in this case, the law of detachment is simply saying, if we know P implies Q, or if we know if P then Q is true, if we truly, there's no question, this is true, and anytime we know that P is true, then Q also must be true. That's an important concept. It seems a little tricky, but really it's not. If P implies Q is true, anytime P happens to happen, it's true, Q must follow. It must also happen. The other law that's very commonly used with deductive reasoning is law of syllogism. Law of syllogism. In this case, it's more like the transitive property, if you remember back in algebra. If P implies Q is true, and Q implies R is true, we can easily conclude then that P implies R is also true. We don't need that middle step because we know that if P happens, Q has to happen. And anytime Q happens, R has to happen. And therefore that whole link, we can exclude that middle step, and we notice that anytime P happens, R has to happen. And that's syllogism. Or like I said, it's a lot like the transitive property you would have studied back in algebra. Once you have that down, but we're going to move on to some more Venn diagrams, and it's just really a lot like we talked earlier in unit in topic 4, except in this case, the Venn diagrams that we're going to talk about are going to take on special situations that are a little more involved. We have A up here in this circle. The bigger circle down below is B. And then we also have C. So we have an event A, an event B, and an event C. And given this information, given this Venn diagram, we know this stands true. Anytime we know this for fact. First, if you look at A is never B or C. Anytime A happens, then B or C will not happen. A never coincides with B. If A is true, B and C are not. In this case, we also have B is sometimes true in instances where C is happening. If you look down here, it's B sometimes happens. B is sometimes C, and C is always B. You know that for sure. C is always B. So A is never B or C. B is sometimes C, and C is always B. And that is all that we really have as far as notes for topic 5. So thank you, and have a good day.